Okay, so this problem is a bit more involved, but it's not bad. All you do is you look at, the first thing they want to know is what is the friction coefficient. So the only equation with the friction coefficient is this one right here, and that's off your equation sheet. Now what we're going to do is take this equation and solve for that variable. So I rearrange it and I get this equation. Now before I finish out and explain how I solve everything, let's look at what we know. Okay, so in this diagram here we have a steel plate down on a surface and it's being pulled by an applied force. There's mass 1 and mass 2, and mass 1 and mass 2 are equal. And it says the velocity is constant, and it also says there is friction and it is moving. So we know the acceleration from that stuff right here. We now know the acceleration is 0 and the net force is 0. So if the net force is 0, that means if there's a force upwards, there must be a force down to balance it out. If there's a force to the right, there must be a force to the left to balance it out. That way the sum of all the forces equals 0. Okay? So let's take a look at this. So if we look at this, we see there's a force applied right here. Okay? Pulling it to the right. But let's draw a free body diagram now, and this is very important, is to take what they've given you and draw a diagram, and then draw a free body diagram with forces. So if I look at it, what force is acting down on this steel plate? Okay, well the mass is weighing down on it, so you got the weight of mass 1, okay, going down. You got the weight of mass 2 going down, right? And then we have the weight of the steel plate is acting on itself too, so it's pulling down. And it looks like the steel plate's quite big, so I drew that one bigger and longer, if you can tell right here. Okay, and then the other thing we want to do is, well, let me undo this. Okay, and then if you look right here, we've got the applied force, okay, and the applied force is pulling to the right. But there must be a force balancing it out, and that's the force of friction. And since it is balancing it out, then it must be equal, and that's why I put the 2 tick marks on both sides. Like in geometry, they're equivalent lengths. Oh, we're missing one other force. All these weights going down has to be counterbalanced or, be matched, like what you said over here, by an upward force. And there's an upward force pushing up. That way, because this steel weight is not sinking through the table or the floor or the surface, so there's a normal force pushing up on it. And therefore, we also know the normal force is equal to the sum of those weights. So that's really, really helpful. So now we also know the friction force is equal to the applied force because the net force is 0. So now we go through the substitution, and we take the friction force over here, and we put in the applied force, and then we put in down below the weight, okay, and weight is just mass times g, like we've got from this basic equation we know. And we're going to simplify it here and go mass 1, mass 2 plus mass 3, and then multiply it by g, which is our 9.8 meter per second squared, which is the acceleration of gravity. And the force applied we know. Okay, now let's do some actual numbers. So some actual numbers. So this is the diagram in the problem. And over here I have 1.7, 4.6 newtons pulling, and each mass, the small mass, is 0.2 kilograms. So I put the 4.6 newtons in the applied force, 0.2, 0.2, 1.7, all added together times 9.8, and then I put that under 4.6 newtons, and I'm going to get 0.22 is my answer. But I decided to show you the units. It's 0.22 newtons on top, but on the bottom it's going to be kilograms times meters per second squared. Well, by definition, a kilogram meter per second squared is equivalent to 1 newton. A newton divided by a newton is 1, and now you see the answer is 0.22. And a friction coefficient has no units. Okay, it's just a number that compares a ratio of the forces. So that's how you solve for the kinetic friction coefficient for this problem. hopefully you see that it's really, really important to understand your basics, going back to the weight equation, choosing the right equation from U sub k, also realizing that if you don't draw a free body diagram like this one, you're going to be all messed up and it's going to be completely difficult. Oh, and then one other hint, this free body diagram is necessary in order to answer the questions in the next problem. So please, please look at that free body diagram and analyze it. Okay, that's it from today on this question.